Okay, I'm Ritwik and today's topic is amines. Amines అన్నది it's a small topic with a lot of reactions. Organic లో లాస్ట్ టాపిక్ లాగా కన్సిడర్ చేయొచ్చు బిఫోర్ బయోమాలిక్యూల్స్. ముందు చాప్టర్స్ రియాక్షన్స్ అన్ని అమైన్స్ లో అప్లికేషన్స్ కింద వస్తాయి. Like amines is a combination of reactions from other chapters except for two three reactions. Hoffman's ammonal, Hoffman's bromine reaction, ammonolysis reaction, ఇంకా benzene diazonium salt reactions and distinguishing tests. పక్కన పెడితే all the reactions are borrowed from other chapters. So let's dive in. Nomenclature కి కొన్ని జనరల్ ఎగ్జాంపుల్స్. Ethylamine, like C2H5NH2 కి its common name is ethylamine. IUPAC name is ethanamine. Common names అన్నది like makes sense in a way. IUPAC names అన్నది they have rules. అమైన్ నామెన్క్లేచర్ కి రూల్స్ ఏంటంటే ఇట్స్ అ ప్రైమరీ అమైన్ దెన్ డైరెక్ట్ గా అమైన్ అని లాస్ట్ లో రాసి ఆ సైడ్ చైన్ కి సెకండ్. ఓకే, సంథింగ్స్ రాంగ్. Why is it not loading? Okay, let me do it this way. Okay, so like primary amines ki it is one from the numbering thing, like join in the నుంచి say CH3 CH2 CH3 and H2 అంటే your numbering starts from here 1 2. So ethane and substituent is your 1 methyl. 1 కాబట్టి 1 is disregarded. Methyl ethane eth and 1 amine. No, like okay, sorry, my bad. Amine is not a functional group. Amine is a like another you can see it is like a side group. So numbering is like normal గానే చేసేస్తాము. Your largest carbon chain. Now it's prop and substituents and levu, so no prefixes. And then your amine is in 2 amine. And CH3 and C2H5 H is secondary amine. సో ఒక్క like one of the substituents should be like parent of amine. ఇక్కడ this has more carbons కాబట్టి this is the parent thing. This is like a substituent. సో ఇప్పుడు ఒక్క పేరెంట్ సబ్స్టిట్యూయెంట్ ఇంకోటి సెకండరీ సబ్స్టిట్యూయెంట్స్ గా చూసుకోవచ్చు. ఈ సైడ్ సబ్స్టిట్యూయెంట్ ఈస్ వన్ జస్ట్ మిథైల్. సో ఎన్ మిథైల్ ఇప్పుడు పేరెంట్ కి సో CH2 CH3 ఎన్ మిథైల్ ఈథ్ ఏన్ అండ్ amine. One amine is usual in one secondary and tertiary amine naming లో it is one amine కాబట్టి one is disregarded. Like one amine లో this is disregarded. Tertiary amine లో so maybe this is the parent chain, these two are side chains, one methyl around. So NN dimethyl meth your parent chain meth and amine. అది normal secondary tertiary and this thing is ending. Enlin ki IUPAC name kuda enlin or benzenamine, but only for enlin ki benzenamine వస్తది. Enlin substituents ki you're gonna use enlin. Ortho this thing is orthotoluidine. NH2 కి ఆర్థోలో CH2 ఉంది కాబట్టి ఆర్థోటాలుడిన్. ఇక్కడ ఉందంటే like two positions outward metatoluidine, paratoluidine. So ఇప్పుడు ఆర్థోకి it's like 2 methylene. So this is 4 methylene, like 1, 2, 3, 4. That's your normal nomenclature. ఇక్కడ బెంజినమైన్ అన్నది you're gonna use it in the last case. And then dimethyl benzenamine. Preparation of amines, lot of methods. Reduction of nitro compounds. ఇక్కడ రెండు ఇచ్చారు, those are important, but there are plenty of other methods to reduce the nitro compounds, like plenty of other conditions. ఇప్పుడు your nitrobenzene ని you reduce it with hydrogen directly using palladium surface and ethanol catalyst. Like ethanol is for basic medium, so that becomes NH2. అలా కాకుండా there is another thing. Like how do we say this? Maybe later. Nitrobenzene with metal HCl use NH2. Nitrobenzene అది కాకుండా this is one additional reaction. nitrobenzene with hidden అక్కడ like tin and iron place లో you can also use zinc ZnNH4Cl or ZnNH4 which essentially neutral medium you will get NHOH partial reduction లాగా అనుకోవచ్చు not needed the reasons like no the reduction is like 5 steps ఆ 5 steps లో reagent బట్టి ఎక్కడన్నా అయిపోవచ్చు your final step is the ending your second reaction is ammonolysis basically NH3 plus I'll take an example C3H8 C3H7X maybe okay maybe RX NH3 plus RX is NH2 R plus HX another RX NH R2 plus HX another RX NR3 plus HX another RX NR4 plus X minus. This is your quaternary ammonium salt. Why is this important? If you reduce this with some AgOH or something, Ag, if I remember it right. Let me know. Ag, then you will get reduced ammonium salt. Half an elimination జరిగిద్ది Hoffman elimination of NR NR3 like nitrogen పోద్ది. Let me show you example later. This is the thing. Order of reactivity Ri greater than Rbr greater than Rcl. Ri bond is weaker, so easy reaction. Reduction of nitriles RCNA H2 nickel. H2 nickel H2 on metal surface in acidic medium or some sort of special mediums. Reduction of cyanides is Hoover blank reduction. It is H2 nickel in presence of sodium amalgam in ethyl alcohol. You will have RCH2 NH2. This is your Hoover reduction. H2 nickel is like very strong reducing agent. So alok reaction. Next reaction is reduction of mides. Mides ki LiH4 is a mixed reducing agent. Direct గా H2 reduction కాకుండా this thing forms complexes and reduces the compound. So RCO LiH4 in presence of water. RCH2 and water is important. Water breaks up the complex of LiLH4. It's Gabriel Thalmide synthesis. Gabriel Thalmide synthesis is used to prepare primary amines. Adi thalmide, what you see is thalmide. First thing, thalmide to you're gonna react it with KOH. NH hydrogen is poorly acidic. So KOH to react this. KOH to react this, you can have N minus K plus. దాన్ని ఆల్కైల్ halide తో react చేస్తే you're gonna have alkyl thalmide. NaOH తో react చేస్తే break అయిపోద్ది. You're gonna have RNH2. Chain reaction లో multi-step reaction లో RNH2 form అయింది. That's only used to prepare primary amines. And Gabriel thalmide only primary amines, aliphatic primary, not benzyl. uh, Benzyl కాదు. Aniline లాగా ఫామ్ చేయలేం. You cannot prepare aniline with Gabriel thalmide. ఇంకోటి హాఫ్మన్ బ్రోమైడ్ degradation. This is the special reaction. CONH2 Br2 NaOH 4 moles of it minimum. You will have RNH2 plus side products. You need 4 moles of NaOH. Like 4 moles lo 2 are gonna be Na2CO3, మిగతా 2 NaDO. Widely used reaction. Physical properties. Amines physical properties are greatly affected by hydrogen bonding. So ఇప్పుడు primary amines లో you can have high intermolecular hydrogen bonding. ఎందుకంటే 4 NH bonds ఉన్నాయి కదా. This shape is more symmetric as shown in the figure. ఇట్లాగా 4 bondings ఉంటాయి. So it is primary amine లో అలా ఉంటే secondary amine and tertiary amine లో you have less number of intermolecular hydrogen bond. బాయిలింగ్ హైడ్రోజన్ బాండింగ్ ఎక్కువ ఉంటే ఇంటర్మోలిక్యులర్ హైడ్రోజన్ బాండింగ్ ఎక్కువ ఉంటే బాయిలింగ్ పాయింట్ ఎక్కువ ఉంటుంది. బాయిలింగ్ పాయింట్ ఈస్ లైక్ primary greater than secondary greater than tertiary. Boiling points of amines, alcohols, and alkenes of almost same molar mass are like I didn't print out the table. మ్యాటర్ ఏంటంటే అమైన్స్ లో ఎక్కువ ఉంటది, దెన్ ఆల్కహాల్స్, దెన్ ఆల్కిన్స్. అనదర్ థింగ్, బాయిలింగ్ పాయింట్ H2O greater than NH3 greater than HF. HF greater than H2O has like, if NH3 unte you can have six bondings, but six are weaker hydrogen bonds. Ikkada four are moderately strong, two highly strong. So you can say this is like experimental result no one could have predicted. So please remember this. Chemical reactions, amines are mildly basic due to the lone pair. Bases so అలా react అయితే it forms RNH4 plus and X minus salt like quaternary ammonium salt laga. Quaternary ammonium salt is prepared by this kind of reaction. And then is even more mildly basic ఎందుకంటే lone pair availability తగ్గింది. And amines are like Lewis bases essentially. Those hydrogens are OH లేవు కాబట్టి these are like Lewis bases. That's one equilibrium reaction. Basically, pKb is minus log Kb and Kb is అక్కడ the OH minus concentration into your salt concentration by RNH2 concentration. Basically, what he is trying to say is larger the value of Kb or smaller the value of pKb, stronger is the base. The way he say this. Basically, he's trying to show basic strength from equilibrium theory. Products concentration ఎక్కువ ఉంటే cause concentration ఎక్కువ ఉంటే basic nature ఎక్కువ ఉన్నట్టు చెప్తారు. What is important is structure and basicity comparison. That is as shown here. Your amine is more basic than aniline ఎందుకంటే structure basicity comparison లో important point is lone pair density on H2 or NH or something is proportional to basicity. Basically lone pair దాని దగ్గర ఉండాలి. Lone pair nitrogen మీద ఉండాలి electron density. In aniline, that lone pair gets delocalized into the benzene ring. Second point is this is the strongest, most general order. First one name is gonadine. It's the most basic and amine thing. Later, gonadine replaced by one CH3. తర్వాత amine, తర్వాత aniline, తర్వాత pyrrole, and last one is your amide. That means this one if it's not visible. And thirdly, your bridged tertiary amine is basic than your normal tertiary amine. ఎందుకంటే bridged tertiary amine has some conditions regarding its hybridization. Its lone pair is more localized. Small tertiary amine లో it is like amine flipping అన్న ఒక కాన్సెప్ట్ ఉంటుంది. దట్స్ డ్యూ టు ది hybridization. In tertiary amine లో amine flipping ఎక్కువ, so your lone pair is more delocalized. But bridged amines లో amine flipping తక్కువ, so its lone pair is not much delocalized. ఇక్కడ delocalized అంటే delocalized in space, not between atoms. So your uh, okay, that's one thing. And another point, like plus charge on the bridge is not stable. Kani, okay, let's stick to the inversion. So అందుకు your bridged tertiary amine is more basic than normal tertiary amine. Ammonia కి like aniline కి donating group ఉంటే your aniline lone pair would have more electron density. So donating group greater than nothing greater than withdrawing group. RCH2 and H2 greater than RCH double bond NH greater than RCN, of course. The RCN is like more minus I. RCH2 and H2 is like plus I. 6 point that thing. This is more basic than this. Ante your lone pair is not free. Ikkada your lone pairs are free, but this is sp3 and this is sp2. So this can donate easy. More or less alternative. Same reason applies for above. And seventh day, it's the famous thing. Methyl NH2, double methyl, triple tertiary amine, tertiary methylamine, and ammonia. Gaseous state low, it's not gonna matter tertiary greater than secondary greater than primary due to like more plus ఏ ఉంటుంది tertiaryలో, తర్వాత secondary primary తర్వాత ammonia. Ammonia has no minus. కానీ aqueous state లో there is a theory called amine flipping. So amine flipping వల్ల your primary has your tertiary flips more. So the lone pair is hard to capture. So as a result of amine flipping and this plus I effect, your basic strength is affected as tertiary greater than secondary greater than primary greater than tertiary greater than ammonia. This is for methyl amines. Amines. Are ethyl amines like ethyl primary, ethyl secondary is like secondary greater than tertiary greater than primary greater than next three. There are some reasons. Basic strength is proportional to solvation, hydrogen bonding, plus effect. Inversely, solvation is inversely proportional to crowding is that's a part of amine flipping theory. Lastly, I just said it here. Alkylation, it's like already covered reaction. Next, 3 plus, and it says RNH2 plus H. This reaction. This is alkylation. Acylation is like that. RNH2K, you're gonna add RCOCl. Up there, you're gonna have this. NH3 plus RCOCl is RCONH2 plus HCl after a lot of equilibrium steps as shown in the figure. Amines also react with benzoyl chloride. This reaction is known as benzoylation. When this R is equal to benzene, no, benzene, then the reaction is called as benzoylation. Development reaction, this is isocyanide test. This is a kind of distinguishing test. Isocyanide test, acidic and aromatic primary amines on heating with chloroform and ethanol in potassium. Isocyanate or carbaramines, these are very foul smelling substances. Secondary and tertiary amines do not show this test. So this reaction is used to identify primary amines. This reaction is also called isocyanide test and is used for the test for primary amines. It's the reaction because PHCl3 is chloroform, KOH is potassium hydroxide. You will get RNC isocyanide. Reaction with nitrous acid, you will have HNO2 reaction is NaNO2 plus HCl లేదా HNO2. HNO2 is formed by NaNO2 plus HCl లేదా డైరెక్ట్ గా వేస్తారు. Then your RNH2 converts into benzene diazonium salt. Like diazonium salt, not benzene diazonium salt. Benzene diazonium salt is stable. Diazonium salts are stable in general because this is benzene stable at room temperature. Due to like it is stable at room temperature because of this conjugation process. When you react this thing with water, it breaks down. Which benzene diazonium salt is used to form a lot of amine reactions. Aromatic amines react with nitrous acid at low temperatures. Yeah, benzene diazonium chloride. Very important class of compounds used for synthesis for a variety of aromatic compounds discussed in section. Benzene diazonium salt is used to synthesize aromatic compounds. Reaction with aryl sulfonyl chloride, that is Hinsberg reagent. Your PHSO2Cl is Innsbruck reagent. It is used to identify, like, distinguish primary and secondary amines. Reaction with reaction of Innsbruck reagent with primary amine yields this. This primary amine with Innsbruck reagent creates a white solid. This is soluble in alkali. Secondary amines are also white solid, which is insoluble in alkali. Alkali is NaOH. Tertiary amine to no, sir. This is used as a distinguishing agent. Heterophilic substitutions, normal reactions, Allen reactions. Br2H2O లో bromination aniline plus 3Br2 in presence of water అయితే tribromination. What you see, 2 ortho 1 para. లేదు aniline bromination like 3Br2 తీసుకున్నా కూడా it won't react in presence of alcohol, ethyl alcohol. You have single para bromination. కిందది that's acylation reaction. Right. NH2 with peroxy CH3 CO twice O in Tilden. That's acylation. Acylation లో your Friedel craft acylation లో your benzene ring will be acylated కానీ ఇక్కడ it's not like that here. NH2 group takes the COCl, COCH3. ఇంకే బ్రోమినేషన్ చేస్తే you will have only monobromination ఎందుకంటే NHCOCH3 is not such a strong base. So tribromination కి possible కాదు. Aniline లో NH2 is a strong base, so your ring is electron rich, so tribromination అయింది. And NHCOCH3 is not such a strong base, so monobromination. మళ్ళీ COCH3 పీకేయాలంటే you have to put it through acidic or basic medium. Your pH NHCOCH3 is N-phenyl. N-phenyl ethanamide, which is acetanilide in short. more reactions. Nitration, normal HNO, nitration mixture తో చేస్తే you have meta more than para greater than meta much greater than ortho. Ortholo you'll have this inter-hydrogen bonding effect. In a good it doesn't matter. There is some reason here. Moreover, in strongly direct nitration of aniline yields oxidation products in addition to nitro derivatives. Moreover, in the strongly acidic medium, aniline is protonated to form the aluminium ion, which is meta-directing. That is why, besides other para derivatives, significant amount of meta derivative is also formed. Take your aniline కాదు, your aluminium ion is also reacting because of the acidic medium created due to HNO3 and H2SO4. Aluminium ion create చేసినప్పుడు your meta NO2 is more stable. However, by protecting the NH2 group by acetylation reaction, you can have more paranitro derivative. ఇందాక చేసినట్టు COCH3 reaction చేస్తే you have more para product in below reaction. Sulfonation, essentially same thing, SO3H added. This is more irreversible than benzene sulfonation. Aniline sulfonation is more irreversible. Benzene sulfonation is very reversible. Just sulfonation చేసి if you add water again మొత్తం రివర్స్ అయిపోయి you have benzene. ఇక్కడ అలా కాదు. This is more stable. Aniline doesn't undergo Friedel-Crafts reaction because it has a base on its top. So AlCl చేస్తే you will have a salt. Ginsberg test is already covered. Hoffman's oxalate test. This is oxalate. You're gonna use diethyl oxalate as a reagent. ఇప్పుడు primary amines reacting with diethyl oxalate, you will have a solid. Secondary amines అయితే liquid. Tertiary amines అయితే you won't have a reaction. Mechanism not really needed, I guess. Hoffman's mustard oil reaction. Mustard oil is because of its smell and appearance. Your reagent is CS2 and HgCl2 on heating. Primary amines, so if you react it with CS2 and HgCl2 heating, you'll have a black PPT and compound having mustard oil smell. Secondary tertiary, you're not gonna have. Compound ఏంటంటే isothiocyanate RNCS. This compound has mustard oil smell. కిందది కార్బోలామైన్ reaction, again primary amine test covered before. RNH2 in presence of chloroform and aqueous KOH gives isocyanide, which has very foul smell. Diazonium salts. Diazonium salts are used to prepare a lot of aromatic compounds and other compounds. Diazonium salts correctగా reduce చేస్తే you can also have amines. Diazonium salts are a very important storage media for amines. Like ఈజీగా చాలా products derive చేయొచ్చు diazonium salts నుంచి. Using the chemical reactions. Some chemical reactions are here as mentioned. You can form this diazonium salts R N2 plus X minus ఆర్ అన్నది సమ్ ఫినైల్ ఆర్ aromatic అయితేనే దిస్ థింగ్ ఈజ్ స్టేబుల్ ఎట్ రూమ్ టెంపరేచర్. అదర్వైజ్ ఇట్స్ నాట్ స్టేబుల్. స్టేబుల్ ఎట్ రూమ్ టెంపరేచర్ అండ్ లిక్విడ్ లిక్విడ్ స్టేట్ లో ఉంటది. Otherwise, it's not stable, it breaks down. So, benzene diazonium salts are an important storage media. Like, దాని నుంచి you can have benzene diazonium salt and చిన్న reaction చేసి you can easily obtain a lot of compounds as shown below. ఇక్కడ you have this aryl NH2 benzene diazonium salt తో if you react it with Cu2Cl2 in presence of HCl, you will have aryl chloride plus NH2. Cu2Cl2 is Sandmeyer's reagent. So this is Sandmeyer's reaction. So Cu2Cl2 is like weak chlorination in in presence of a metal catalyst. So that's one thing. After Gatterman reaction, copper in presence of HCl. This is more strong. How do you say? More strong chlorination. ఎందుకంటే Cu is a more stronger catalyst than Cu2Cl2. So this reaction is Gatterman reaction. The yield in Sandmeyer reaction is found to be better than Gatterman reaction. Strong doesn't necessarily mean good color. In Cu to Cl2, your Cu has to go from Cu plus 1 to Cu. ఇక్కడైతే Cu plus 2 to Cu. This is more rocky when compared to this. ఇది simple గా అయిపోతుంది. So your yield in Sandmeyers is better. Cu plus 2 నుంచి Cu అంటే it takes a lot of time and energy. ఇంకోటి reaction replacement by iodide ion is by directly treating with Ki. దీనికి if you use a catalyst like Cu, అప్పుడు reaction is very reversible and slow. సో డైరెక్ట్ గా Ki వేస్తారు. బట్ ఫ్లోరిన్ ion తో రీప్లేస్ చేయాలంటే మాత్రం యూ హ్యావ్ టు డూ ఇట్ ఇన్ ఎ వెరీ కంట్రోల్ వే. HbF4 యాడ్ చేస్తాం. దిస్ రెడ్యూసెస్ ది స్ట్రెంగ్త్ ఆఫ్ F మైనస్. లైక్ ఇంకా తక్కువ అవైలబుల్ ఉండేలా చేస్తుంది HbF4 because this has this equilibrium kind of thing. HF plus BF3. So it's not like complete HF. Equilibrium లో ఉంది కాబట్టి only some HF. So that's the reaction again. ArN2 plus BF4 minus. This compound is even more stable, complex. So this thing reacts on heating. You will have ArF and lot of steps. Reaction by hydrogen. Certain mild reducing agents like phosphenic acid or ethanol reduce diazonium salts to arenes and themselves get oxidized into phosphorus acid and ethanol. Mild reducing agents used just like those are enough. H2 palladium anta strong are not necessary. See the reaction. H3PO3 plus H2O plus your benzene diazonium salt gives ARH plus N2 plus H3PO4 plus HCl and respectively in the reaction. Replacement by hydroxyl group is just by adding water. So benzene diazonium salt ke water esse you're gonna have all this phenol. So benzene diazonium salts are sold in a specific media. Benzene medium, if I remember, not in water. Replacement by NO2 group. again done by HbF4 is like Lewis acid, and this reduces the strength of benzene diazonium salts. It makes it more inert. This this thing is more inert. N2 plus BF4 minus. ఇది ఒక కాంప్లెక్స్ అండ్ ఇప్పుడు దీంతో బెంజీన్ డయాజోనియం సాల్ట్స్ రియాక్షన్ కావాలంటే యూ నీడ్ సమ్ ఎనర్జీ టు బ్రేక్ దిస్ కాంప్లెక్స్. సో దిస్ థింగ్ ఈస్ మోర్ ఇనర్ట్. సో reducing pH N2 plus BF4 minus in presence of Na2 reacting with NaNO2 in presence of copper and heating, you will have NO2, nitrobenzene. Last reaction, reactions involving retention of diazo group, coupling reactions. Benzene diazonium salt plus phenol gives coupling reaction. Basically, how is it? This is your benzene diazonium salt plus phenol. Phenol ఈ hydrogen and ECl minus get out to give this kind of compound. This thing has an orange dye. So these coupling reactions are used as identification tests for benzene diazonium salts. Complete గా అయిందా లేదా? These are strong dyes, these couple compounds. కింద they did the reaction with aniline that also works. Phenol and aniline both give coupling reactions. So that's it for theory. So couple of questions. Three isomers give the following results. Molecular formula is C8H11N, so maybe one benzene ring, one CH2, CH2, and nitrogen. So no unsaturation based on the thing. DUS equal to 0 other than benzene. ANC gives diazotization reaction to give R, P plus Q. Wait, what is this? R plus S. Question is not so much clear. P plus Q on hydrolysis and okay, let's skip that question. Question is not that much clear. Benzene diazonium chloride on reaction with aniline in the presence of dilute hydrochloric acid gives your coupling reaction. The C option. Coupling reaction ki your media is HCl dilute. So option C. Increasing order of pKb. Did I mention that before? Okay. Coupling reactions ki your media is HCl. It weakly activates the complexes. Okay. No, no, wait. Ah, my bad. I didn't mention this before. Your phenol coupling ki your reagent is dilute HCl. అదే NH2 aniline coupling కి yeah, no, mild base NH2 coupling కి mild acid. Why అంటే your NH2 in presence of mild acid turns into NH3 plus and OH in presence of mild acid turn into O minus. So it like activates this thing. O phenol activates in mild base medium and NH2 activates in mild acid medium to form the coupling reaction. So in that question, the reaction is coupling reaction and aniline కాబట్టి your reagent is mild acid. Increasing order of pKb of the following compounds. These are like your guanidine things. So donating group strength చూసుకుంటే your OCH3 greater than CH3 greater than F greater than NO2 BDAC. జస్ట్ నైట్రోజన్ మీద డొనేటింగ్ స్ట్రెంత్ ఎక్కువ ఉండేలా చూస్తే ఓకే మై బ్యాడ్ దిస్ ఈజ్ ది కేబీ ఆర్డర్ pKb is reverse C greater than A greater than D greater than B. Donating withdrawing group strength చూసుకోవాలి. So the following is not a correct method for preparation of benzylamine from cyanobenzene. Benzylamine is your aniline. Aniline is benzylamine. Cyanobenzene is this thing. D reaction is your direct reduction reaction. How do we say this? Your second option is your Bohr blank reduction kind of thing. Uh, this is cyanobenzene. This is benzylamine. H2 nickel works HCl H2O. Your C won't work ఎందుకంటే LiAlH4 వేస్తే it forms a complex with this RCN. The mm, N plus ALH3 minus. It will complex form చేసి you're not gonna have a reduction reaction. So C option won't work. Fourth case, C is not a correct method to prepare benzylamine from cyanobenzene. So that's it for today. Visit the NTA app for more practice.